Good evening, everyone. So, I've shared you the question paper which is related to some basic concepts of chemistry, right? How many of you guys tried solving it? I don't want you guys to complete it. At least, I want you, I hope you have started it at least. Rakshan, Senthamil Chelvan, Sharmila. Okay, Senthamil Chelvan, you have started it, right? Was the paper easy? How was the paper? Was it easy or moderate or difficult? Moderate, okay. Okay, right. How about Sharmila and Rakshan? So, what shall we do today? Shall we discuss the question paper? Shall we? Okay. So, actually, the paper is about some basic concepts of chemistry. So, we may encounter questions like the question may related to limiting reagent, molar masses, and concentrations and its expression, and maybe about isotopes and all that. Okay, fine. And significant figures. And most importantly, mole concept. So are you guys thorough with those thorough with those concepts? Rakshan, Sharmila. Okay. Shall we discuss the paper now? Shall we? Rakshan, Sharmila. Fine. Okay, I'm going to give you a question, a random question from this paper. Kanna, can anyone read out this question? See, this is very simple question, and I think we have discussed this pattern of problem in our class. So, which has so they're asking us to calculate the number of molecules in each option, and we have to find which got maximum number of molecules. So the concept is basically from mole concept, right? So here the options are in grams. We have to convert weight into number of moles and number of moles to number of molecules, right? So what is the formula or what is the flow chart we have discussed already? Have to convert weight to number of moles. The formula is number of mole is equal to given mass divided by molar mass. And to convert number of moles into number of molecule or number of chemical species. What is the formula, Kana? Or what is the condition to convert number of moles to number of chemical species?
Multiply by Avogadro number.
Yeah. Correct, sir.
Correct, madam.
Correcting, sir.
Oh, just now joined. Avogadro. Okay, multiply by Avogadro number.
Yes.
So what is happening?
So
You all
here,
agree? No, why it is so such a simple concept which I studied 35 years back, 40 years back. I was able to remember. செந்தமிழ் செல்வன் வாய் திறந்து சொல்லுங்கண்ணா. ஏன்னா நீங்கள் சொல்லலைன்னா அவங்களுக்கு தெரியாது. உங்களுக்கு என்ன தெரியுங்கிறது அவங்களுக்கு தெரிஞ்சாதான் அது தகுந்தாப்புல அவங்க தெரியலன்னா தெரியலன்னு சொல்லுங்க. நோ ப்ராப்ளம். Absolutely no issues. Sharmila, you can, I hope you can understand Tamil. So if you don't know, you say I don't know. That's nothing wrong in it. Okay, madam. Carry on, madam.
okay, sir. Okay. So here in all the options, the quantities are in weight. So Senthil Chelvan's answer is option A. We'll check now. So in option A, the given mass is 8 gram. So to calculate number of moles, given mass is 8 gram divided by what is the molar mass of hydrogen? Molar mass of hydrogen. H2, so atomic mass of hydrogen is 1. So 2 into 1 is 2. So 2 gram per mole. And in second option, the given mass is 64 gram. And what is the molar mass of sulfur dioxide? What is the molar mass of sulfur dioxide? Atomic mass of sulfur is 32 and atomic mass of oxygen is 16. What is the molar mass of sulfur dioxide? Yes, 64 gram per mole. And in option C, it is 44 gram of carbon dioxide. And molar mass of carbon dioxide is? It is also 44, right? So 44 gram per mole. And in option D, given mass is 48 and molar mass of ozone. Molar mass of O3. Atomic weight of oxygen is 16.
$48, ma'am.
Very good, Kana. 48. 48 gram per mole. So from this we can calculate the number of moles, and from number of moles we can calculate number of chemical species. So here it is 4 mole, here it is 1 mole, here also it is 1 mole, and here also it is 1 mole. So among all the 4 options, first option got maximum number or maximum number of moles. So obviously this got maximum number of molecules. So our answer is option A. One more question. See, what volume of oxygen gas measured at 0 degrees Celsius and 1 atmospheric pressure is needed to burn completely 1 liter of propane gas whose molecular formula is C3H8 measured under same condition. So the question is from limiting reagent, right? Or basic stoichiometry. So the process is combustion of propane gas. So for combustion of propane gas, we have to calculate how much volume of oxygen gas required at the given condition. That's it. So the formula of propane gas is C3H8. This is the molecular formula of propane gas. And for combustion, obviously we need oxygen gas, right? So C3H8 plus O2 gives, upon complete combustion, what will be the product? Upon complete combustion, what will be the product? Carbon dioxide and H2O. Right, Kana? So the first step is we have to convert the process into chemical equation, and second step is we have to balance the equation. Here it is not a balanced one. Please balance this equation. Left side I have 3 carbon atoms, right side I have only 1 carbon atom. Right, left side I have 8 hydrogen atom. Right side I have just 2. So please balance carbon, hydrogen and oxygen atoms on both sides. So left side I have 3 carbon atoms. So right side also I should have 3 carbon atoms. How about hydrogen? Left side I have 8 hydrogen atoms. So right side also we need 8 hydrogen atom. So what number I have to write in front of H2O?
4.
4. Very good. So carbon and hydrogen were balanced. Now we have to balance the oxygen.
5O2.
Very good, Kana. That's it. So what is the inference here? In terms of number of moles, 1 mole of propane requires 5 moles of oxygen to give 3 moles of carbon dioxide and 4 moles of H2O. That's it. So here the ratio between propane and oxygen gas is 1:5. So can you please solve now? Here the inference is in terms of number of moles, but the question is in terms of volume. So how to do that? We know at this condition, at standard temperature and pressure, 1 mole of gas occupies how much liter? How much liter? What is the molar volume? 22.4 liters. So this is the clue. Can I listen here? If 1 mole of propane requires 5 moles of oxygen, then it is same in liters also. If 1 liter of propane requires how much liter of oxygen then? It is just the unitary method. How much, Kana? 5 liters, obviously. Are you guys getting my point? Shall we move on to next question? Rakshan?
Yes, ma'am.
Okay. Here is the question. Volume occupied by 1 molecule of water is dash. We have to calculate how much volume was occupied by just 1 molecule of water. The clue is density. See, what is the density of water? It is 1 gram per centimeter cube. So what inference we can make from this data? See, it is 1 gram per centimeter cube. So what it mean? 1 gram of water twice 1 centimeter cube of volume. This is the inference, right, Kana? So if 1 gram of water occupies 1 centimeter cube of volume, then we have to find how much volume was occupied by just 1 molecule of water. What shall we do? What shall we do? See, 1 gram of water occupies 1 centimeter cube of volume. Suppose 18 gram of water occupies dash centimeter cube.
18 centimeter cube.
Very good, 18 centimeter cube. 18 gram is nothing but 1 mole of water. 1 mole of water is nothing but Avogadro number 6.023 into 10 power 23 water molecule. Right? So from this what we can infer is 6.023 into 10 power 23 water molecule occupies 18 centimeter cube. Then 1 water molecule occupies dash centimeter cube. It is x. Please cross multiply and let me know the value of x. So what is the value of x? 18 divided by 6.023 into 10 power 23.
1.0 into 10 to the power minus 23.
Come again, Rakshan. Come again, Kana.
3.0 into 10 to the power minus 23
Very
centimeter
good.
cube.
Very good. It is option 4. That's it. Shall we move on to next question then? Sendami Chelvan, you're getting my point? It is not option C, it is option
Yes,
4.
ma'am.
Okay. Okay, here is the question. The total number of electrons in 1.6 gram of methane to that in 1.8 gram of water. So we have to calculate the number of electrons in 1.6 gram of methane and 1.8 gram of water, and we have to find the relationship between them. So I'll give you a minute, Kana. Please try solving this. See, please calculate the number of electrons in one molecule. From that data, derive the data for rest of the parameters. Okay. Sendamil Shelvan's answer is same. Okay, fine. We'll check, Kana. Rakshan and Bhumika, do you want a clue? We'll check. Okay. So first we'll calculate it for methane. In one molecule of methane, how many electrons are there in only one molecule of methane? In one molecule of methane, how many electrons are there? In carbon, in one carbon atom, we have 6 electrons. And in one
10, ma'am?
hydrogen atom, we have 1 electron. So we have 4 hydrogen atoms. Yes, it is 10 electrons totally. So in one molecule, it is 10 electrons. Okay. So which means an Avogadro number of molecule, Na is nothing but Avogadro number. In Avogadro number of molecule, how many electrons are there? Avogadro number into 10 electrons, right? So what is Avogadro number of molecule? It is 1 mole of methane, right, Kanna? I want it in terms of grams because the question is in terms of gram. So 1 mole of methane is nothing but 1 mole of methane is nothing but it is 16 gram of methane, right? So 16 gram of methane contains Avogadro number into 10 electrons. So the question is 1.6 gram of methane contains how many electrons? It is Avogadro number into 10 into 0.1. That's it. So it is 0.1 into Avogadro number of electrons. Right, Kana? So similarly, we have to calculate it for water molecule H2O. So one molecule of water contains how many electrons? How many electrons in only one molecule of H2O?
10, ma'am.
Very good, it is 10. So similar calculation in Avogadro number of molecule. Again, Avogadro number into 10 electrons, right, Kana? So Avogadro number of molecule is nothing but 1 mole of water molecule. 1 mole of water molecule is nothing but 18 gram of water molecule, right? So 18 gram of water molecule contains Avogadro number into 10 electrons, and the data here is 1.8 gram of water molecule contains how many number of electrons, which is Na, that is Avogadro number into 10 electron into 0.1. So it is actually the same, right, Kanna? So it is actually Avogadro number. It is 10 power minus 1. This is 10. So it will get cancelled out. So Avogadro number of electrons. That's it. So it is just the same. So answer is second option. Any doubt? Any doubt? So this question is from mole concept. That's it, Kanna. Shall we move on to next question?
Yes, ma'am.
Could you show me the 8th question, ma'am?
Sorry?
Could you show me 8th question, ma'am?
I'll show you.
Thanks, ma'am.
Okay. Now
Okay,
we
ma'am.
solve. Okay, Kana. So, 10th question. Can you try solving this? 10th question. Try to solve this question. Here, the question is when X molecules are removed from 200 milligram of nitrous oxide, 2.89 into 10 power minus 3 moles of nitrous oxide are left, and they're asking us to find what is the value of X. Here the problem is the unit. See here, initial quantity of nitrous oxide was in gram, and the final quantity was in moles, and they're asking us in molecules. They're asking us the quantity in molecules, right? So please convert all the parameters to molecule, then subtract and let me know the value. So in the initial quantity of nitrous oxide was 200 milligram, right? So calculate the number of molecules in 200 milligram, and the final quantity of nitrous oxide was a number of moles. Convert this number of moles into number of molecules. Okay, so you'll be having initial quantity and final quantity. Subtract both the number, you'll get the value of X, the quantity of molecule removed from the given quantity of nitrous oxide. Okay, so please calculate and let me know. So first let me know the number of molecules present in 200 milligram of nitrous oxide. So you have to use the mole concept again. What is the molar mass of nitrous oxide? What is the molar mass of nitrous oxide? N2O. Atomic mass of nitrogen is 14 and atomic mass of oxygen is 16. So what is the molar mass of N2O?
44, ma'am.
So
44, ma'am.
nitrous oxide is 44
44.
gram. Yes, it is right, Kana. It is 44 gram. So what it mean? 44 gram is nothing but 1 mole of nitrous oxide. So 44 gram of nitrous oxide contains 6.023 into 10 power 23 molecules, right? N2O molecule. So, if 44 gram contains Avogadro number of molecule, then 200 milligram contains how many molecule? So, 200 milli is 10 power minus 3 gram contains how many number of water molecule? So, calculate and let me know the value of X. So, how to do that? See, 6 into 10 power 23 into 200 into 10 power minus 13 gram divided by 44 gram. So cancel all those numbers and please let me know the value. So 6 into 10 power 23 into 2 into 10 power 2. 200 I'm writing it as 2 into 10 power 2 into 10 power minus 3 divided by 44. So let me know the values, Kanna. So this is 1 time, this is 22 time, and cancel the 6 and 22 and let me know the value. So 6 by 22 into 10 power 22, right? So what is 6 by 22? What is 6 by 22?
3 by 11.
Yes, Kana. Divide and let me know the value. You're right, it is 3 by 11. What is 3 by 11? 0.27 approximately, right? So the value of x is 0.27 into 10 power 2. See here, the x, what I mean is number of molecules of nitrous oxide present in 200 milligram of nitrous oxide. Okay, so the initial quantity present was 0.27 into 10 power 22. 22. Now calculate the remaining or the resultant number of molecules present in 2.89 into 10 power minus 3 mole of nitrous oxide. See, this is the initial quantity. This is the final quantity. We have to subtract the initial and final to find the value of x, right? So now we found the initial value of nitrous oxide. So please find the final value of nitrous oxide in terms of number of molecules. So here it is in terms of number of moles. So you have to convert that into number of molecules. So you have to multiply it with Avogadro number. So 2.89 into 10 power minus 23 into 6 into 10 power 23, right? So 2.89 into 6. So 2.89 into 6. Sendable children, what value is that, Kana? 2.7 into 10 power 20 is? What number was that? Okay, what is the value of what is the value you're getting if you multiply this 2.89 into 6?
17.34.
Very good. Okay. So 17.34 into 10 power
20.
20. That's it. So this is the initial quantity. This is the final quantity. You have to subtract both the values to find the value of x. So while you are subtracting, make sure the power of 10 is equal. So we can have it as 27 into 10 power 20. So this is the initial value, which is 27 into 10 power 20. And remaining, the resultant value is 17.34 into 10 power 20. Approximately, I'm going to have it as 17. So what is the value, Karna? 27 minus 17 into 10 power 20. So 27 minus 17 is 10 into 10 power 20. So what is the answer? What is the answer?
21.
Sorry, Rakshan?
10 to the power 21.
Its answer is option 4, 10 power 21. Okay. So here also the concept is mole concept, right? So basically we have to convert weight into number of moles and number of moles into number of molecules. That's it. Next question. This is the question from limiting reagent and it is very easy. Try solving this, Kanna. 4 gram of hydrogen reacts with 20 gram of 4 gram of hydrogen reacts with 20 gram of oxygen to form water. The mass of water formed is dash. So first from this process, write the equation, balance the equation, make the inference from the equation and find the limiting reagent and finally find the mass of water formed. I'll give you a minute. Try solving this, Kanna. So Sendamal children's answer is option C. How about Rakshan?
For hydrogen, it is 2 moles, ma'am.
Okay.
For oxygen, it is 0.625 moles, ma'am.
Very good. So from this data, we have to find how much mole of water was formed. So among this, which is the limiting reagent reaction? Is it hydrogen or oxygen? So what is the balanced equation for this process?
Ma'am, oxygen is limiting reagent, ma'am.
Very good, Rakshan. Oxygen is the limiting reagent. So basically, the equation is hydrogen reacts with oxygen to give a water. So to balance this equation, I'm going to have it as 2 water molecule and 2 molecules of hydrogen. So it is balanced now. So the inference is 2 moles of hydrogen reacts to give 1 mole of oxygen to give 2 moles of water. And the data given is in terms of grams. So it is 4 gram of hydrogen, 20 gram of oxygen. So we have to convert uh, given data, that is which is in gram to number of moles. How to do that? 4 gram divided by 2 gram per mole. 20 gram divided by 32 gram per mole. So by simplifying, Rakshan told the value as 2 moles of hydrogen reacts with 0.625 mole of oxygen. So basically the inference is quantity of oxygen required is half the quantity of hydrogen, or the quantity of hydrogen required is 2 times the quantity of oxygen, right? So they are in the ratio of 2 is to 1. Here uh, the oxygen's quantity is just 0.625. So what is the inference? The quantity of oxygen required is the half the quantity of hydrogen. Initially, if the number of moles of hydrogen is 2, then the number of moles of oxygen required is 1. Here, it should be 1, right? Because the given number of moles is 2 moles. So oxygen has to be 1 mole. But here in given data, the oxygen was just 0.625. So it is the quantity is lesser than the quantity actually it is required for the process. So this is considered to be the limiting reagent. So according to the inference, if the oxygen's number of mole is 1, then the water formed will be 2 moles, right? Here the ratio is 1 is to 2. So quantity of water formed will be 2 times the quantity of oxygen. So here oxygen was 0.625. So what will be the number of moles of water formed? It is 2 times the quantity of oxygen, right? So the quantity or the number of moles of oxygen is 0.625. So a number of moles of water formed will be 2 times, right? Which is,
1.25.
come again, Kana?
1.25.
Very good. 1.25. 1.25 mole of water formed. But here they're asking us to express it in weight. So convert this number of mole into mass. Have to do that. Number of mole is equal to given mass divided by molar mass. So number of mole is 1.65 mole and molar mass of water is 18 gram per mole. So please simplify and let me know the value of that is mass of the water. 1.25 into 18. It is actually 22.5. That's it. Send children. You told me initially, you told me the value as option C, right? It is 22.5. It is right, Kana. We'll move on to next question. Shall we?
Yes, ma'am.
Fine.
Yes,
Next
ma'am.
question. Okay, Kana. So here, which has the maximum number of molecules? Now, is it possible for you guys to solve this? It is easy, right? You now have to solve this problem, right, Kana?
Option B, ma'am.
Okay. So it is option B, right? So we have solved the same pattern initially, right, Kana? Now we'll move on to next question, 13th question. The number of molecules present in 4.25 gram of ammonia. So here the data is in mass. We have to convert that into number of molecules. Please convert and let me know the value. It is also from the mole concept. So Sendamil children's answer is option 2. Uh-huh. Kana, how about Rakshan, Bhumika, Sharmila? Yes,
Ma'am,
Bhumika?
option B, ma'am.
Option B, right. That's it. So shall we move on to next question? Shall we? Okay. Here is the
Yes,
question.
ma'am.
Okay, Kanna. So here is the question. The maximum number of molecules present in which of the following? Here, in each option, the quantity is given differently. In first two options, the quantity was given in liters, and last two options, the quantity is given in gram. So we have to convert gram into number of moles and number of moles into number of chemical species. And in first two options, the quantity is given in liters. So we have to convert that into number of moles and number of moles into number of molecules. How to do that? See at STP, 1 mole of gas, 1 mole of any gas occupies 22.4 liters. That's it. Here is the clue. So if 22.4 liter was occupied by 1 mole of gas, in first option the volume was 15 liters. So if it is 15 liters, then that is how much mole. So from this, calculate the number of moles in each option and come up with the maximum number of molecule. Easy. Please calculate in checks and the children. May not be option C.
Ma'am, option A, ma'am.
Option A. Very good. So if it is 15 liter of gas, then how many number of moles of hydrogen were there? What was the number of moles of hydrogen in option A, Bhumika? See, 22.4 liter was occupied by 1 mole of gas. Then 15 liter was occupied by how many number of moles?
0.67, ma'am.
That's it, 0.67 mole. And this is 15 liter, it is 0.67 mole. This is 5 liter, definitely that will be lesser than 0.67 moles. So obviously we don't want to solve this option at all because they are asking for maximum number of molecules. So it will be definitely lesser than option A. And in option C, the given mass is 0.5. 0.5 divided by molar mass of hydrogen is 2. So it will be definitely lesser than option A, right? And here it is 10 gram. 10 gram divided by 32 gram per mole. Right, Kana? So what will be the answer? Definitely option A. That's it. Sendami Chelvan, you're getting my point? It is not option C, Kana, it is option A. Any doubt? Rakshan, Sharmila, any doubt? Fine. Next
No, ma'am.
question. Okay, Kana. Next question. I think we have solved this pattern of problem already. The number of atoms in zero point 0.1 mole of tetraatomic gas is dash. They are talking about tetraatomic gas. What it means? One molecule contains 4 atoms. Okay. Please solve this problem and let me know the answer. Okay, Sendamal Children's answer is option C. How about Bhumika, Sharmila, Rakshan,
Ma'am, option C,
Adila?
ma'am.
Option C. Okay, right. So answer is option C. If you have any doubt, please let me know or we'll move on to next question. Sharmila, Rakshan, if you guys want me to solve, we'll solve together. Adila, you want me to solve now? If you want, please let me know. I'll do it. Yes, Rakshan? Okay, we'll solve together. Listen here. They're talking about tetraatomic gas. So what it mean? One molecule of gas contains four atoms, which means 10 molecule contains how many atoms? 10 molecules contains 40 atoms, which is 4 into 10 atoms. Right, Kana? Similarly, Avogadro number of molecule contains how many atoms? 4 into Avogadro number of atoms. Right? Avogadro number of molecule is nothing but 1 mole. Right? So 1 mole of gas contains 4 into Avogadro number is nothing but 6.023 into 10 power 23. So 1 mole of gas contains this many number of atoms. They're asking for zero point 0.1 mole. So zero point 0.1 mole of gas contains how many atoms? That's it. So X is equal to 4 into 6 into 10 power 23 into 0 0.1. So what is this? 6 into 4 is 24 into 10 power minus 1 into 10 power 23. So which is 2.4 into 10 power 23. So answer is option C. Adila, Rakshan,
Yes, ma'am.
any doubt, Kana?
Mm.
No, ma'am.
Fine. Now, next question. See, how many grams of sodium hydroxide should be added to water to prepare 250 ml of solution of 2 molar sodium hydroxide? So here the question is from concentration. More specifically, it is from molarity. You know the formula of molarity. We have to find the number of moles of sodium hydroxide required. So what is the answer? Adila, Rakshan, Bhumika, Sendam
Ma'am, option
Chilvan.
C.
Option C. Is it 20 gram? Right, it is right. Adila, any doubt? Rakshan, if you guys want me to solve, I'll do it. Sharmila, or shall we move on to next question? Shall we? Okay. So here is the question. Hemoglobin contains 0.334% of iron by weight. The molecular weight of hemoglobin is approximately 67,200. The number of iron atom present in one molecule of hemoglobin is dash. Atomic weight of iron is given as 56. So this question is from mass percentage of element in a compound. So please solve this problem, Kana. We have only one formula there, and the question is very direct. Please substitute the given values and let me know the number of iron atom present in one molecule of hemoglobin. If you don't remember the formula, please let me know. I'll give you. Okay, Senthamal Children's answer is 4.008. How about Adila? Rakshan, Bhumika?
Ma'am,
Do you
option
guys
A, ma'am.
remember the formula? Yes, it is option A, right? So Bhumika's answer and Sendamal Shelvan's answer is right. It is option A. So here is the question. In the reaction, 2 moles of sulfur dioxide reacts with 1 mole of oxygen to give 2 moles of sulfur trioxide. When 1 mole of sulfur dioxide and 1 mole of oxygen are made to react to completion, then dash. All oxygen will be consumed. 1 mole of sulfur trioxide will be produced. Zero point 0.5 mole of sulfur dioxide is remained. All of these. So the question is basically from limiting reagent.
Option B, ma'am.
Okay, Kana. So it is option B. Okay. Bhumika, what is your answer? Rakshan, Sharmila,
Option B, ma'am.
option B. So shall we move on to next question? Shall we?
Yes, ma'am.
So here is the question. If the weight of metal chloride is x gram, if the weight of metal chloride is x gram containing y grams of metal, then the equivalent weight of metal will be dash. So they're asking us to calculate the equivalent weight of the metal. Shall we do it together? If you guys want any
Yes,
clue, let me know. Okay. Shall
Ma'am,
we do it?
option C, ma'am.
Option C. How, Bhumika? Have you got this answer? Is there any formula, direct formula to solve this?
Ma'am, weight of the metal வந்து Y, ma'am. Weight of the chloride வந்து X minus Y, ma'am.
Mm-hmm.
Into 35.5, ma'am.
Yes. So you're talking about you're talking about some specific formula, I guess, right? Okay, fine. So Bhumika's answer is option C. Rakshan, Sendamil Shelvan? Sendamil Shelvan? Fine. So let us do together. Listen here. First, we have to know what is equivalent weight. See, for example, I'm going to take a metal M. Weight of metal required to react with 8 gram of oxygen to give metal oxide. So this W1 is the equivalent weight of metal M. Okay, so quantity of the metal required to react completely with 8 gram of oxygen is called the equivalent weight of metal. Okay, or weight of the metal required to react completely with 35.5 gram of chlorine to give some metal chloride. Okay, so this W1 is the equivalent weight of the metal. You're getting my point? You're getting my point, Kanna?
Yes, ma'am.
So let us write the equation. For example, W1 gram of metal is reacting with W2 gram of chlorine to give some chloride. So to give some metal chloride. Okay. So here the equation is W2 gram of chlorine is reacting completely with W1 gram of metal. So what is the equivalent weight? It is not for some random W2. So here the definition is specifically W1, the quantity of metal required to react completely with 35.5 gram of chlorine. So how to do that? So which means 35.5 gram of chlorine requires how much gram? That is X, right? So how to calculate this X? So X is equal to W1 into 35.5 divided by W2. So what is this W1? Weight of the metal. What is W2? Weight of the chloride. That's it. What is X? That is the quantity of metal required to react completely with 35.5 gram of chlorine, which is your equivalent weight. Right? That's it. So this is the formula to calculate equivalent weight. So equivalent weight is equal to, what is W1, Kana? W1 is the mass of metal divided by, what is W2? Mass of chlorine into 35.5. That's it. This is the formula Bhumika was talking about. So what is the mass of metal in this given question? What is the mass of metal?
Y.
Y gram. What is the mass of chlorine? See, total weight is X. So total weight of metal chloride is X. And in that mass of metal itself is Y. So what will be the weight of chlorine then? X minus Y, right? So Y divided by X minus Y into 35.5 is the equivalent weight of the metal. So obviously the answer is option C. That's it, Kana. Shall we move on to next question? Any doubt? Adila?
No, ma'am.
Sendamid Shelvan?
No, ma'am.
Rakshan Sharmila? Shall we move on to next question? Okay. Very good, Bhumika. You told me the answer right. So here is the question. See, this, I think we have already solved this question. Same question we have solved in our class. Please solve and let me know the number of moles of water produced. Sandhamil Chelvan, Sharmila, if you guys want any clue, please let me know, or else I'll give you time. You solve at your end, please let me know the value. Bhumika, Rakshan, do you guys want any clue? The question is basically from limiting reagent.
4 moles.
Okay, Rakshan's answer is 4 mole. Sendamil Chelvan's answer is also 4 mole. How about Adila? Bhumika?
4 moles, ma'am.
4 moles. Okay. So, Adila, what is the answer, Kana? Or if you want me to solve, we'll do it together. I'll do it. Please let me know. Shall we do it together?
Yeah.
Okay. So here they are talking about some process where 10 gram of hydrogen is reacting with 64 gram of oxygen to give water. So whenever the question is from limiting reagent, we have to write the equation related to that process. So hydrogen is reacting with oxygen to give water. And of course, we have to balance this equation. So here it is 2 moles of water and 2 moles of hydrogen. So the inference what we can derive from this equation is 2 moles of hydrogen is reacting with 1 mole of oxygen to give 2 moles of water. But the data given here is in terms of grams. So it is 10 gram of hydrogen and 64 gram of oxygen. And they're asking us to calculate the number of moles of water. So whenever the data is given in terms of weight, we have to convert that into number of moles. To do that, it is 10 gram divided by 2 gram per mole, which is 5 mole. And how about oxygen? 64 gram divided by 32 gram of, 32 gram per mole of oxygen, right? So what is the number of moles of oxygen then? 64
2,
divided
ma'am.
by 32 is 2 mole, right? So what is the inference? Quantity of the oxygen required is half the quantity of hydrogen. Here, hydrogen's quantity is 5 mole. So oxygen we need is 2.5, but here the quantity is just 2 mole. So here the limiting reagent is oxygen, right? So now this limiting reagent will decide the quantity of the product formed. If the oxygen's quantity or if the oxygen's number of mole is 1, then the water molecule formed will be 2 moles. In the given data, the number of moles of oxygen is 2. So number of moles of water formed will be how much?
4 more.
4 mole, that's it. So answer is fourth option. Okay, fine. Now shall we move on to next question? Shall we?
Yes, ma'am.
Okay, so here's the question. Here they are asking us to calculate the number of electrons. We have solved this kind of problem, but there the quantity was okay. The substance was number of the molecule. The question was they asked us to calculate the number of electrons in given quantity of molecule, but here it is number of electrons present in ions. So we have to be very careful with the charge given. So here the ion is N3 minus. They're asking us to calculate the number of electrons present in 4.2 gram of N3 minus ion. Instruction?
C. Option C.
Option C. Sendamal Chelvin's answer is also option C. Okay. Bhumika, any doubt? Sharmila, Adila?
No, ma'am.
Okay. Adila? If you have any doubt, please let me know. Here the answer is option C. If you guys want me to solve it, please let me know. I'll do it. Okay. Can I listen here? In one ion, how many electrons are there? See, generally in nitrogen, the atomic number of nitrogen is 7, which means number of proton is 7 and number of electron is also 7, right? So in nitrogen itself, there are 7 electrons. But in this ion, this got extra 3 negative charges. So the total number of electrons present in one ion itself is 10. Right? Okay. So in one ion, there are 10 electron. But they're asking it in terms of gram, right? How to do that? What is the atomic weight of nitrogen? What is the
14.
atomic weight of nitrogen? It is 14. So 14 gram of iron contains how many electron? We can do it step by step. Listen here. One ion contains 10 electrons, which means 10 ion contains how many electrons? 10 into 10 electrons, right? So 20 ion contains how many electrons? 20 into 10 electrons, right, Kana? So similarly, Avogadro number of ion contains how many electrons? Avogadro number into 10 electrons. You're getting my point? Avogadro number of ion is nothing but 14 gram of iron, right? Because Avogadro number of iron is nothing but 1 mole of iron. 1 mole of iron is nothing but 14 gram of iron, right? So 14 gram of iron contains Avogadro number into 10 electrons. Now they are talking about 4.2 gram of iron. So 14 gram of iron contains 10 into Avogadro number, which means 4.2 gram of iron contains how many number of electrons? You just cross multiply and let me know the number of electrons. 10 into 4.2 into Avogadro number divided by 14. What is the value of X, Adila? What is the value of X?
3, ma'am.
3. That's it. The answer is option C. Now, next question. The number of moles of nitrogen in 1 liter of air which contains 10 percentage nitrogen by volume under standard condition. Under standard condition is dash. Actually, in air, we have 10 percentage of nitrogen by volume, and they are talking about 1 liter of air. In 1 liter of air, how many number of moles of nitrogen is present? If you guys want any clue, please let me know. I'll give you. See, they are talking about 1 liter of air. Okay. 1 liter of air contains just 10 percentage of nitrogen by volume. So, what is the 10 percentage in 1 liter? 1 into 10 by 100, right? So, what is the 10 percentage then? It is 10 power minus 1 liter, right, Kana? So in 1 liter of air, it is 10 power minus 1 liter of nitrogen is present. So it is nothing but 0.1 liter of nitrogen. right? So from this we have calculated the number of, I mean, we have calculated the volume of nitrogen. So in this volume of nitrogen, we have to calculate the number of moles of nitrogen, which is very easy. They are talking about standard condition, right? And we know the molar volume. So 1 mole of any gas at STP occupies 22.4 liters. And here they are talking about 0.1 liter of nitrogen. So 0.1 liter of nitrogen contains how many moles? Please cross multiply and let me know the answer. So what is the answer? What is the answer? What is the answer, Kanna? It is just the unitary method. You have to find the value of x. Cross multiply this and let me know the value of x. So 1 mole into 0.1 liter divided by 22.4 liters, which is equal to x. Liter will get cancelled out. So it is 1 into 10 power minus 1 divided by 22.4 liters. I mean 22.4. Yes, Kanna, what is the answer?
0.00446.
So answer is
D option.
very good. That's it. Shall we move on to next question? Okay. It is very easy. It is also from limiting reagent concept. Liquid benzene burns in oxygen according to this given equation. I think it is balanced one. And they're asking us to calculate how many liter of oxygen are needed to complete the combustion of 39 gram of liquid benzene. Very easy. Do you guys want any clue? Bhumika, Rakshan, Sharmila? If you want any clue, please let me know. So, what is the answer? If you guys finding it difficult, please let me know.
Option C, ma'am.
So Sendamil Chelvan's answer is option C. Kana, can you please check your calculation? What is the molar mass of benzene?
78 gram per mole.
78.
Yes, it is 78 gram per mole. Okay. So it is not option C. But molar mass of benzene is right. See, what is the inference? 2 moles of benzene requires 15 moles of oxygen, right? 2 moles of benzene requires 15 moles of oxygen. How many moles of oxygen is, how many moles of benzene is this? It is just 39 grams. So 39 gram of benzene is nothing but how many number of moles of benzene?
Half mole.
Yes, it is zero point 0.5. So 0.5 mole of benzene requires how much oxygen? So calculate the number of moles of oxygen from this unitary method, and from the number of moles, let me know the value of let me know the value of volume. What is the value of x? X is equal to 15 into zero point 0.5 divided by 2, right? So what is the number of moles of oxygen required for complete combustion of 39 gram of liquid benzene?
3.75.
Yes, it is 3.75. So if it is 3.75 mole of oxygen, then that is dash gram of that is dash liter of oxygen. So what is the molar volume? 22.4 liters
In,
is equal to 1 mole. So here it is 3.75 mole.
so 74 liter.
You just need to cross multiply this. That's it.
It works out to 74, I think. Sorry. Yeah.
Ma'am, option D, ma'am.
Option D
84.
is actually 84, sir.
84.
84.
84. Yeah.
84, yes.
Correct.
That's it. So I think we need to solve 7 more problems. So we'll do it together in the next class, okay? Or if you have time, please solve those 7 problems and share it in the group.
Yeah, try these problems. I mean, even if you go wrong, it's all right. Send your answer sheets. Even if you go wrong, it's all right. This is a place to make mistakes. Classroom is a place to make mistakes, not the exam. Exam, you are not supposed to make mistake. Classroom, you can make mistake. Okay, thank you, madam.
Okay, sir.